In recent astronomical observations, scientists have detected something extraordinary. A significant object has collided with Neptune, the eighth and one of the most mysterious planets in our solar system. This incident has stirred up significant excitement and some concern within the scientific community, sparking discussions about the potential consequences for Neptune and the solar system as a whole. Though cosmic collisions aren't new, an impact on a gas giant like Neptune is rare and provides unique insights into the dynamics of our solar system. Such an event may help scientists uncover new details about how celestial bodies interact, the composition of distant planets, and the possibility of similar occurrences elsewhere in our galaxy. Neptune, discovered in 1846, remains largely mysterious due to its great distance from Earth, approximately 4.5 billion kilometers away. This distance makes it challenging for astronomers to study Neptune up close, as it is only occasionally visible even with powerful telescopes. However, recent advancements in observational technology, including the Hubble Space Telescope and various Earth-based instruments, have allowed scientists to monitor Neptune with unprecedented detail. It was with these powerful tools that astronomers first observed an unusual anomaly in Neptune's atmosphere, signaling that a significant event had taken place. The collision itself, based on initial data, appears to have involved a massive object, likely an asteroid or a small comet, crashing into Neptune's atmosphere at an incredible speed. Unlike Earth, Neptune lacks a solid surface, as it is primarily composed of hydrogen, helium, and methane gases. When an object collides with a gas giant, it penetrates the thick, swirling atmosphere, creating dramatic disturbances. Scientists observed telltale signs of an impact, including a bright flash that lasted for several seconds and subsequent waves of turbulence in the planet's upper atmosphere. These waves, visible in the infrared spectrum, were captured by telescopes from observatories worldwide, providing strong evidence that a collision had indeed occurred. The aftermath of the collision has generated a lot of interest among planetary scientists. Collisions on Neptune are rare, but when they do occur, they offer valuable information about the planet's atmosphere and the solar system's outer regions. When an object strikes Neptune, it releases energy that can alter the atmospheric dynamics, creating shockwaves that move through the planet's gaseous layers. Observing these shockwaves allows scientists to study Neptune's atmospheric composition and how energy is transferred within it. This collision may also help scientists understand the impact of cosmic debris on Neptune's climate, which remains one of the least understood in the solar system. Unlike Earth, which has a relatively stable and predictable weather system, Neptune experiences extreme weather patterns, including the fastest winds recorded in the solar system, reaching speeds of up to 2,100 kilometers per hour. One of the most concerning aspects of the collision is the potential for residual effects on Neptune's atmosphere and its moons. Neptune has 14 known moons, with Triton being the largest and most intriguing. Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation, suggesting it was likely captured by Neptune's gravity rather than forming alongside it. This unusual orbit makes Triton particularly susceptible to changes in Neptune's gravitational field, which could theoretically be altered by a significant impact. While scientists don't expect drastic changes to Neptune's gravitational pull, any shift, however slight, could influence Triton's orbit or even affect its icy surface. Triton has an exceptionally thin atmosphere and active cryovolcanoes, which could respond to changes in Neptune's gravity. In addition to studying Neptune's atmosphere and moons, scientists are interested in the object itself that collided with Neptune. In our solar system, countless small celestial bodies, including asteroids and comets, travel through space, occasionally intersecting the paths of planets. The Kuiper Belt, a region beyond Neptune, contains numerous icy bodies, some of which occasionally stray toward the inner solar system due to gravitational disturbances. These disturbances often arise from interactions with large planets like Neptune, whose immense gravitational field can redirect the paths of objects passing nearby. Scientists believe that the object which collided with Neptune may have originated in the Kuiper Belt, shedding light on the dynamic nature of this distant region and the potential threats it poses to planets in our solar system. The possibility of a second collision or a chain reaction of events has not been ruled out. Cosmic debris often travels in clusters, meaning that when one object collides with a planet, it can be followed by additional debris moving in a similar trajectory. Scientists are monitoring Neptune closely for signs of any additional impacts or unusual activity that might indicate the presence of other objects. Such a scenario, while rare, is not unprecedented. Jupiter, for example, has experienced multiple impacts from clusters of objects, including the famous Shoemaker-Levy 9 comet collision in 1994, which provided valuable insights into the nature of gas giants and the destructive power of cosmic impacts. Another point of concern is the potential for this collision to influence Neptune's magnetic field. Unlike Earth, which has a relatively stable magnetic field due to its iron core, Neptune's magnetic field is much more complex and irregular. Scientists believe this may be due to a combination of factors, including the planet's rotation and the movement of conductive materials within its atmosphere. A significant impact could, in theory, disrupt the magnetic field temporarily, leading to changes in the planet's radiation belts and possibly even affecting its magnetosphere. These changes, though temporary, would provide valuable data on how gas giants maintain their magnetic fields and how they interact with the interplanetary magnetic field that permeates the solar system. This collision also raises broader questions about the stability of our solar system. While space is vast, and most objects travel through it without incident, planets like Neptune act as gravitational guardians, capturing or deflecting potentially dangerous objects that could otherwise pose a threat to the inner planets. In a sense, Neptune's gravitational influence plays a role in protecting Earth and its neighboring planets from potentially catastrophic impacts. By studying collisions on Neptune, scientists can better understand how these protective mechanisms work and assess the potential risks posed by objects in the Kuiper Belt and beyond. Additionally, these events help refine existing models of orbital mechanics and the behavior of objects influenced by planetary gravity. While the collision itself is a significant event, it also serves as a reminder of the constant activity taking place in our solar system. Far from being a static collection of celestial bodies, the solar system is a dynamic environment where objects interact, collide, and evolve. By observing these events, scientists gain a deeper appreciation of the forces at work and the ways in which planets like Neptune influence the broader cosmic environment. This collision, in particular, may offer unique insights into the formation of gas giants, the evolution of planetary atmospheres, and the interactions between celestial bodies in the outer solar system. As researchers continue to study the effects of this impact, they are likely to make new discoveries that will enhance our understanding of Neptune and its role within the solar system. The data gathered from this collision will contribute to ongoing research and may even inform future missions to explore Neptune and its moons more closely. Although sending a spacecraft to Neptune is challenging due to the planet's distance from Earth,